Precal Academic, Unit 2.8 notes. Good. Okay. I might use the board for this first one here, okay? So we're looking at the 2.8 notes. Number 1, we're going to start doing, so we talked about polynomial equations and rational equations, okay? Now we're going to talk about inequalities with them, okay? We're going to talk about inequalities, okay? Miss White told me to do this, and I think it's a good way she told me to do it. So she told me to have you guys solve these graphically. So I have you guys solve these graphically, which is good. I think it's a good idea. That's how I like to do it too, right? I feel like we know how to graph polynomials decently easily, okay? This is my good marker. No, it's not. We know how to graph decently easily. Okay, cool. So let's, little XY plane, right? Little XY plane. Let me make sure the. Okay. All right. How do I? So we want to number 1 determine where this function is positive, 0, and negative. Use interval notation. Okay. You guys see the function there? Someone tell me, how can I graph that? How can I graph that function?
Find your zeros.
Yeah. What are my zeros?
-7, -4, and 6.
Yeah. So you're gonna get -3 is gonna be one of them. Right here. I'll write the zeros.
You were doing a different. You were doing 2.
Oh, sorry. I'm looking at number 1. I'm sorry. Highlighted in orange. Doing this one. Okay. So it's going to be x equals -3 is one of our zeros. Okay. I guess I should say we only want the real zeros. Okay. X equals 4 is going to be one of our zeros, and then this factor right here, that would give me what? What would the zeros that would give me? Yeah, it'd give me plus or minus I, right? So I only want the real zeros because we only use the real zeros when we're graphing. Okay. Okay. What's the multiplicity on each of these zeros? What's the multiplicity, and how do I know?
1, 2.
Yeah, so 1, which is odd, and then 2 for 4, which is even, right? Right. Why do I want the multiplicity when I'm graphing?
So it bounces.
Yeah, see where it bounces. Okay, so here's -3. Here's 4. Here's 4, okay? All right. And then what's my, so what's the degree of this polynomial? What's the degree of it? And how do we find the degree when it's all expanded out here? It would be 4. Anyone know where I got 4 from? Yeah, I added up these exponents, right? So the degree is 4. Degree is 4. Lead coefficient. What do I need to know about the lead coefficient? Do I need to know what it is or just what? It's positive or negative, right? So the lead coefficient is going to be this number that's here. Technically, it's a 1 here. So it's positive lead coefficient, right? Positive, I'm going to say LC. Positive LC, okay? So we plot our zeros, okay? We know it's odd degree, so what's the end behavior? Is it going to be the same on both sides or opposite? Or it's even degree, isn't it? Sorry, yeah, so it's going to be the same, yeah. Right? How do we know whether it opens up or down? Positive, so it's going to open up or down? Yep, it's going to open up, right? So it's going to come, it's going to look like this right at the ends. All right, it's going to look like this at the ends and come down to this first 0 here. Does it go straight through there or does it bounce? Does it go straight through my first 0? Why straight through? It's odd, yes, it's going to go. Okay, and then what's going on here?
How is that going to work?
Yeah, how's that going to work?
It's not.
What's that?
Couldn't you just factor out the x squared to get the zeros of 1?
Oh yeah, no.
No, it could be plus or minus I. Maybe it's only the maybe it's only the real. Oh, okay, sorry about that.
I was singing, bro.
Okay. Yep. So what's going on here? What's going on here is it looks like it looks like we just ignore this imaginary 0 here. It looks like we just ignore the imaginary 0. So now, I'm sorry about that, guys. So now our degree is 3.
So it's an odd.
Yeah, that's weird.
So it starts from the bottom.
Yeah, it starts from the bottom. Oh shoot, now it's here. So degree of 3. Lead coefficient's still
Are
positive,
we
right?
graphing it?
Yeah, we're graphing it. Yeah.
Oh, I thought-
So now I have, sorry about that. I have an odd degree. I only care about the real zeros here is what's happening. Okay, I only care about the real zeros. Okay. So I have an odd degree. The zeros are in the same spot. We just got our end behavior wrong. Yeah, the zeros are in the same spot. Okay, so it's odd degree. So what does the end behavior look like? So you're gonna look like the same or different? Different, right? That's because it's odd degree. Okay, and positive lead coefficient. So it's gonna look like this or like this? Like what? Let's do A or B. A. Okay, good. Yeah. Go straight through the first zero. Bounce off the second one. Go straight up. All right. So this is good enough. This is a good enough graph to answer the question. They wanted to know. They didn't want you to graph it. They wanted to determine where the function is positive, where it's 0, and where it's negative. Right? Okay. So I think we all know where it equals 0. Where's the function equal to 0? Where does it equal 0? So what are zeros, guys? -3, yeah. So x equals -3, x equals +4, and then for positive, we need to write down intervals for these, right? We need to write down intervals where the function's positive. Okay. Where is the function positive and why? Anything greater than. Yeah, Ben's on the right track. Where'd the answer come from though? How'd you come up with that?
Where -3 is on the graph, it's the split between the down and the up in the graph and positive.
Yeah, he's on the right track. Yeah, so anywhere, right, it's going to be positive. F of x is going to be positive where the graph is above the x-axis. And it's going to be negative where the graph is below. The graph is below the x-axis, okay? All right? All right, so here, right, this vertical boundary, right, to the right of that dashed line, I'm above the x-axis, except for what point? Except for what point there? 4. So how do I write the interval for the positive region? It's going to be when x equals what? It's when it's in what interval?
-3 to 4.
So -3 to 4. Do I get parentheses there or brackets? What are we thinking? We want where it's positive, right? We want all the points where it's positive. If I use brackets, that's like a contradiction, right? Because I'd be telling you, well, it's equal to 0 at -3, but it's also positive. So we need to use parentheses, okay? We need to use parentheses, okay? -3 to 4, and then what, Colleen? Colleen's.
I'm confused. No, I'm not.
Okay.
Wait, what were you asking?
So -3 to 4, then I need to write what? Because I'm
Positive infinity?
yeah, so union 4 to positive infinity, right? So that's where it's positive. That's where it's positive, okay? And I'm going to get rid of this real quick. Where is it negative? Where is it negative? Where am I negative? Elise, where am I negative?
Below the x-axis.
Yeah, so what x's is that?
Below -3.
Yeah, good job. Negative infinity to -3. Now you get parentheses. Because I'm not negative at -3, I'm 0 at -3, okay? All right, how are you feeling about this? Not too bad? Not too bad. Okay, good. Yeah?
So, is all that stuff on the graph, or on the board, is that all for 1?
No, number 1?
Yeah.
This is all for number 1.
Didn't you say that it was like that?
Yeah, so I made a mistake. So it turns out when we're it was like that because, I guess I should probably. So what happened was we had non-real zeros here in the middle, okay? Because this is a non-real zero, we just threw it out and we only used the real zeros. We only took the real zeros into account to figure out like the degree, the lead coefficient, all that. Does that make sense?
So with an odd degree, then it's like the not both like opposite sides.
With an odd degree, yeah, they're opposite. Okay. Number 2, then we should have a little more solve. So what do they want us to find? They want us to take this polynomial and find where what is the case?
X is less than.
Where the graph is less than the x-axis or on the x-axis, right? Less than or equal to 0, okay? How do I do that? What do? We graph, right? We graph, okay? So all these zeros are real, so let's take all of them into account, okay? All of them into account, okay? So what are my zeros here? Good job. Yeah, we got -7, -4, and +6. What's the multiplicity? I'll do the multiplicity in red. What's the multiplicity? For x equals -7, what's that? Yeah, it's odd. It's 1, which is odd. -4, 1, which is also an odd number. What about +6? 2, which is an even number. All right, 2, which is an even number. Okay. What's the degree of this? This one is actually 4 now, right? We have all real zeros. We add up all the exponents. All right, let me color code that. Degree is 4 because we added 3 purple numbers together. Okay. All right. What's my lead coefficient going to be? 1. So lead coefficient is positive. LC positive. Okay. That's all we need to graph it, right? That's all we need to graph it. Let me try to make a little mini graph over here. Good job. Good stuff. Good stuff. Cool. Okay. So where do I put my zeros? Yeah. So -7, -4, and +6. All right. End behavior is what? It's an even degree, so it looks like what? This or that? This, right? Lead coefficient is positive, so it looks like that. Okay. So we're going to come up. We're going to come down from infinity. Go straight through -7, right? And then straight through -4. Okay? Come back up, and then we're going to bounce off 6. We're going to bounce off 6. Okay. And we want what? So okay. When people are doing math problems, they get caught up in like all the details, and they forget where they were going, just like Moses did when the Hebrews were walking through the desert, okay? So we want what? We want what? What is this graph going to tell us? How does this graph give us our answer? It's less than or equal to 0, right? So what part of the graph are we looking for? What part of our graph is our answer? Yeah, everything below or touching the x-axis. So this is a little different, right? Last problem, we were looking for everything that was just below when we talked about negative. Now we want it's less than or equal to 0. So we want everything that's below the x-axis, but everything that's on the x-axis as well. Okay? So -7 to -4, right? That's going to be 1 interval. Okay? Am I going to get brackets this time or parentheses, and why?
Brackets.
Get brackets, yeah. So it's less than or equal to 0. If it was just less than 0, I'd get parentheses. Right? But it's less than or equal to 0. How do I do interval notation to say, and then just 6? So it's going to be a U, right? I think you see that, okay? Yeah, so maybe people might think this, and, hey, who was thinking this? 6, 6? Was anyone thinking that? Okay. Yeah, so you might think that. That's not technically the correct notation. If we're just trying to add to our interval one lonely number by itself, you do a 6 and a squiggly. And squiggly brackets. Okay. A little confusing. But if you're doing interval notation, you need to do an interval with only one number in it, you do squiggly brackets and just put the one number. Okay? So more notation. We love set notation in mathematics. Yes.
So if you were to put union 6 with parentheses, is that like an actual number? Will that ever be a thing in mathematics?
No, that in all of mathematics, like 6 with just that.
Yeah, is that
That's notation's not used. Not for set notation. It's used for like multiplication if you're trying to like multiply by 6, obviously, but no. It's not a thing. It's not a thing. right? Just like the English alphabet, only has 26 letters, right? 27th letter is not a thing. Kind of like that. No one's come up with it. Right? How are we feeling? We feeling okay?
Yeah.
Can we do number 3? Number 3. So what do we need to do for number 3? What's that? Factor. Yeah, it's factor. Yep. So a little bit of group in here. Yep. So we're gonna factor. Good stuff. Am I factored all the way?
No.
No, what do I need to? Yeah, I got a difference of squares up there. Okay, so I'm not done factoring, I got a difference of squares. Good, so we got our zeros. What are our zeros then? X equals -1, x equals +1, x equals +4. X equals +4, okay? X equals +4. All right, what's the multiplicity on these? For everyone? Yeah, 1. Hopefully we should know this by now. Degree is what? What's the degree of my polynomial, JJ?
3.
Yeah, good job. And what is the sign of the lead coefficient? Maddie, what's the sign of my lead coefficient?
1.
Yeah, it's 1. Yeah, so it's positive. All right, that's everything we need to graph it. That's everything. All right, so this material builds off of what we were talking about. Right, we have to still be able to find the zeros of a polynomial, okay? It doesn't go away. So let's graph these zeros. And +4, okay. End behavior, right? What is it? Is it the same on both sides or opposite end behavior? Yeah, is it like this or like this?
Yeah.
Like this?
Yeah. Shouldn't it be? No. So.
Positive lead coefficient. So it starts over here and it ends going. All right. So let's graph this. I go straight through or I bounce off for all 3 of them? Straight through. Good. Good. And don't forget what you were looking for. Maybe it's not a bad idea to highlight the inequality sign there. I want what? Everywhere the graph is where? Above the 0. What about equal to 0? No, just above, just above, just above. Okay? Just above. Good. You give me? Oh, okay, cool. All right, cool. So it's going to be what? What's my answer going to be?
Pardon this interruption. All band members are to report to the band room. All band members are to report to the band room.
Cool.
Thank
And
you.
then what? -1, 1, union, 4 to infinity, yeah. Yeah, we do pretty well with interval notation in this class. Pretty happy. Good. Okay. How are we feeling about that one? Not too bad. Not too bad. Number 4. Solve this polynomial. I got to find the zeros, right? What can I do with this one? Can we group it? What does it group into? What can I pull out of that? Can I pull a 2 out? I'm not seeing how this is a grouping. I think it's just PRRs. But before I spend lots of time, before I waste lots of class time doing PRRs, I make sure that's what I'm supposed to do. This is number 4. Oof. All right, yeah, so you do have to do PRRs. Yeah, Miss White did PRRs. Here's a little hint, though. She gave a hint. So you actually don't have to do PRRs. Sorry. Because I'm giving you a hint. One of the zeros is x equals 2. So now what do I do? Or sorry, negative 2. It's negative 2. Yeah, I got to do synthetic division, give myself an easier polynomial to work with. Cool. So now I have, so one of my zeros is x equals negative 2. So maybe I'll highlight that in pink. And then we have 2x squared minus 11x plus 12 equals 0. Okay. All right. That factors to 2x minus 3 times x minus 4. Right? Equals 0. So what are our 3 zeros then? So we have x equals 4 as one of them. What's the other one? 3 halves, yep. And what's the multiplicity for each of those? So if we were to write this out in a factored form, you get x plus 2 times 2x minus 3 times x minus 4 is greater than 0. Okay. Do you see where that came from, where the factored form came from? The hint was x equals negative 2 is one of the zeros. Yeah. Yeah. Right, so then what's my multiplicity for each of these? It's 1. Okay, what's my lead coefficient? It's equal to what? 1, so it's greater than 0. What's the degree? 3, which is greater than, 3. Okay. Okay, so we have everything we need to graph it, okay? I don't want to spend too much time talking about graphing these because we already went over that. I want to make sure we get through this lecture. Okay. All right. Okay, so let's draw our coordinate axes. Plot your zeros, negative 2, 3 halves, and 4. Okay, my end behavior looks like what? We should make like an end behavior dance. What's my end behavior look like? Okay, it looks like this. What? All right, looks like that. Oh, I love end behavior. All right, so that's my graph, and I want what? Don't forget, maybe it's not a bad idea to highlight. Highlight what you want. We want everywhere the graph is where? Everywhere the graph is where? Greater than 0, right above the x-axis. That's going to be negative 2 to 3 halves. Do I get parentheses here or brackets, and why? Parentheses, why is that?
Because it's not like on 0.
It's just greater than 0, yeah. So then union, okay, I'm using deja vu really badly. Okay, yeah, union 4 to infinity. Okay, sorry. It's just like the last problem. I mean, look. That was really trippy. It's like, wait, did I just do the same problem with him twice? All right, yeah, sorry, terrible handwriting. I'm sorry. 4 to infinity. 4 to infinity. All right, calculators out. Let's go. Yeah, he's back. All right, get your calculators out. We're going to teach you how to solve this with a calculator. Okay, so first step. First step. What do you guys think my first step is? No, don't plug it in. Yeah, so step 1 here. Oh my goodness, that's a nice camera. Is that the school's or is it yours? Oh man.
We gotta watch JJ's videos.
Yeah?
It's insane.
Really?
Yeah.
That's awesome.
He's like really good.
Really? Hey,
Really good.
hey, you can make a lot of money off that. Yeah, he's got it. You really can. You can cash out.
It is.
Really? That's sick. 5 figures? That's awesome. Okay, so first thing we do, I'm just going to write this down for myself. All right, first thing we do here is we want to get everything on one side of 0. So I'm going to subtract the 2 and add the ax. I want everything on the left side. Why do I want everything on the left side? I want my lead coefficient to stay positive, basically. Cool. JJ's side hustle. That's pretty awesome. You already have a side hustle. All right. No, not right now. All right. Okay, so let me pull up my calculator. I like this better than calculate 84. All right. So what we're gonna do here, I got this purple polynomial up here. Okay. I'm gonna graph that. Okay. So hit y equals clear. Okay. X cubed x to the third. Okay. Minus 6x squared plus 8x minus 2. Minus 2. So this is the exact same as the other problems we've been doing, except you put it in your calculator, basically. There we go. No, you don't have to. All right, and we want everywhere where. Let's not forget where we were going. It was less than or equal to 0, right? So we want everywhere where. Everywhere it's below the x-axis. And on the x-axis. Thank you for the. All right. So how do we do that? How do we find my zeros? What do I do? Yes. Okay. Second calc. Yeah. We want 0. We want the 0 function. Okay. Works the exact same as the extrema function. So verse 0. 0. So from negative. All right. So yeah. So from negative infinity to 0.324, or 325, so from negative infinity to negative 0.325, oh, thank goodness, union, what else? So the second 0, it's going to be the second 0 to the third 0. $1.46. Sorry, these should be brackets. These should be the second one should be a bracket here. What was that number? I said 1.46. 461. What's that third 0 there? 4.21. Good. I feel like this isn't too bad. Thank you. Just make sure you put the right symbols here. Why did I put brackets and not parentheses? It's, what's that? Yeah, less than or equal to 0, yeah. And negative infinity, why does that got a parenthesis? Because infinity always gets parentheses. Yeah, don't put a bracket on infinity. Part of me dies every time. I die inside every time I see a bracket on infinity. All right, number 6. Number 6. Solve with calc. Solve with calc. Yeah, so you literally just graph it. You just graph it, okay? So it's going to be, let me put that in. So graph it. You'll find what here? So what are my zeros here? We should expect to see what? Both of my zeros, or I have 4 zeros here. They're all what? So if we tried to find this first 0, we'd get x squared plus 7 equals 0, or x squared equals negative 7, or x equals plus or minus I root 7, right? So all of my zeros are non-real. They're all imaginary, okay? So what's going to happen is when we graph it, because the graph has no real zeros, it's never going to intersect the x-axis, okay? So what's our answer going to be? No. So we want everywhere where?
Negative infinity, positive.
Yeah, we want everywhere the graph is above the x-axis, which is everywhere. Okay, does that make sense? Yeah. So a lot of high school math students get all real solutions and no solutions mixed up. Okay, this isn't all reals. Okay, look at this second one. Okay, you don't even have to graph the second one to know what the answer is. It's the same function, right? It's the same function. Okay, we know it's above the x-axis everywhere. So where is it below the x-axis or on it? Nowhere. So what's my solution? No solutions. Just put empty set. Put a 0 with the slash through it. The empty set is the set with no elements. And there are no numbers in that set. Because there are no numbers, you can plug in to make that less than or equal to 0. Okay? No one can do it. I don't even know if God can do it, actually. God can do all things which are metaphysically possible. Okay? So omnipotence means that God can do anything that's not a logical contradiction. So God can't make a square circle. Right? He's still omnipotent, right? Because square circle, that's a meaningless phrase. Logical contradictions are meaningless phrases, okay? So I say, if I tell you God can't make a square circle, that's the same thing as me telling you God can't. Okay, that's the exact same. No, they're logically equivalent. Anyway, a little theology lesson today. What's up?
Okay, wait, so like, you said anything is metaphysical.
Yeah, we got to keep going. I'm sorry. I digress.
Metaphysical and logical contradiction. So like, what's the difference between that?
Metaphysical and logical. I shouldn't have used the word metaphysical, but
That might be an equation like what they make.
God can't make 2 + 2 = 5. He can't make contradictions because contradictions are meaningless. Like the phrase is meaningless.
He can't do what?
Okay, well, some scientists like can argue that like some of the events in the Bible are logical contradiction. I'm just like, I don't agree necessarily.
Yeah.
Like, I'm just kind of like,
Yeah. So I mean, so the Bible is not every book in the Bible is historical. It's like Jonah, like the story of Jonah. It's understood as an allegory.
okay.
It's not considered as like a historical narrative. Some books are, like Samuel, 1 and 2 Samuel.
The Newer Testament's more like logical and
Just split.
Well, yeah, I mean, think about like the story, like the Bible contains theological truths, and those theological truths don't have to come through historical narratives. They can, but they come in many different forms of literature. Yeah, right. Just like if you read like Great Expectations by Charles Dickens, there's a lot of truth in that book. Did the story actually historically happen? No, but like there's a lot of true things in that book. Yeah. Anyway, let's go to number 7. Sorry, I'm sorry, guys. I shouldn't have done that. All right. Solve. What do you guys want me to do first?
Multiply the bottom by the top.
Multiply the bottom by the top.
You multiply the top by x.
Yeah, so, okay, guys, low-hanging fruit here. The low-hanging fruit is to multiply, right? We want to get rid of that denominator, right? So we multiply both sides by x minus 3, right? Why do I not want to do that? This is getting into some, why do I not want to do that? What's that? No, why do I not want to multiply both sides by x minus 3?
Oh, it would leave the coefficient as negative. No.
You're on the right track. So x minus 3, right? When I multiply both sides of an inequality by a negative number, I need to do what? I need to flip the sign, right? Is x minus 3 negative or positive? We don't know. We don't know. So because we don't know, we're going to go the safe route. Okay? The safe route, all right, so get rid of this. All right, the safe route is to instead subtract 4 from both sides. So you'll get x plus 1 over x minus 3 minus 4 is less than 0. And then I do what? What have we been doing? Hi, Alberto. What have we been doing with our rational functions? What do I want to do with that 4? I want them my two terms to have the same what? I want them to have the same denominator. How do I do that on 4? How do I give 4 the same denominator as x plus 1 over x minus 3?
You have to give.
Yeah. Multiply the top and bottom by x minus 3. We'll get x plus 1 over x minus 3 minus 4 times x minus 3. X minus 3 is less than 0, okay? Right? We've been doing this, and I combine my numerators. So I distribute and combine like terms, right? Right, good. And then we solve this. We solve this equation right here, or this inequality, the exact same way we did the polynomials, right? So we're going to graph it and see where the graph is where? Below the x-axis. Yes, let's do that. So my zeros, what are my zeros here? Zeros are what? Is it? Yeah. 13 over 3, yeah. So it's going to be x equals 13 over 3. Where are my vertical asymptotes? Where are my vertical asymptotes? Positive 3, right?
Oh, yeah.
Yeah. What's my E? Do I need? Yeah. What's my EBA? This is good practice anyway. What's my end behavior asymptote, Colleen? What's up, Colleen? Answer. So the degree of the top is what? The degree of the bottom, the degree of the top are both 1. So my EBA is what? Y equals 0. Y equals 0. Okay. Y equals 0. Okay. All right. So let's graph this real quick. All right, so let's put our 0 on there. 13 over 3, that's a little over 4. Okay, let's put our vertical asymptote on there. Oh yeah, do your y-intercept too, I'm sorry. Guys, I'm so sorry, I always forget that. What's my y-int here? What do I get when I set x equal to 0? I get negative 13 over 3, right? So a little bit over negative 4, or below. We're doing positive 13 over negative 3. Isn't that positive 13 over negative 3?
Yeah.
Yeah. Yeah, so there's my y-int. My EBA is just the x-axis. Okay. Right, so what's going to happen, actually, my y-intercept is a point that's below 0, right? So the graph is going to be negative here, and it'll be what? To the right. At 4, plug in 4. If you plug 4 into this function, you get a positive. So it's going to be positive right here. So what's going to happen is it's going to come, my function's going to come, it's going to be going down to the left of this vertical asymptote. It's what?
It's positive 13.
No,
Yeah, so if you plug in 0, these two terms go away, you get plus 13 over negative 3. Sorry. All right. And then up here it's positive, so it's going to come, it goes to the right of this vertical asymptote, it goes up to positive infinity. Then it comes down through here, crosses my 0. Yeah, does it cross my, I think it crosses that 0. Right? It's got it, right? Yeah, and I think it comes up like that. This is weird. How does that work? Okay, Miss White's graph looks very different from mine. Okay, so where is this? So where is this below the x-axis then? Where's this graph below the x-axis?
Negative infinity.
To that first vertical asymptote, right? It's below the x-axis all the way here over to that first vertical asymptote, which is 3. It's negative infinity, which is 3. Why do I get a parenthesis on 3? It's because it's undefined. And then union is going to be 13 over 3 to positive infinity. Okay. So for Monday, let's finish those 2.8 notes. Look at Mrs. Ford's lecture video. There's just 3 problems left. So look at Mrs. Ford's lecture video for that, and then do the 2.8 homework. We'll have a review day Monday, test Tuesday. Okay? Does that sound okay? It is a little soon. Let me. I'll talk to.